Yo guys, Tanmaya for Simple Snippets, and today in this programming tutorial we are going to be discussing about inline functions and default parameters. So in the previous video tutorial we discussed about the functions in C++, what they are, how to use them, what is function prototype, what is function body, and everything about the theoretical aspect, as well as we implemented a program which had a function. So if you have missed that video, you might want to check out the previous video, because this is sort of like a part 2 of that video wherein we are going to discuss different variations in functions, as in some type of function, as well as how we can add default parameters to the functions. So if you don't know what functions are, I would recommend you to check that video first. I'll link in the description, as well as you can see a pop-up over here. And with that being said, let's get started with today's video. So in this video we are going to be talking about inline functions, what are inline functions and how are they different from normal functions, and we are also going to talk about how to use default parameters. So let's talk about inline functions in C++. Let me just read out the definition. So if a function is inline, the compiler places a copy of the code of that function at each point where the function is called at compile time. Okay, so this was pretty easy to just mention it in one line. We'll see how it works behind the scenes, that is what happens exactly when the compiler runs through an inline function, and we'll see how it is different from a normal function. So moving ahead, any change to an inline function would require the function to be recompiled, because compiler would need to replace all the code once again, otherwise it will continue with the old functionality. And lastly, we have the syntax, wherein we just have to add a keyword that is inline before the return type. So if you just miss out or don't write this inline keyword, this function would be a normal function. So the only difference in the syntax between a normal function and an inline function is this keyword inline. So we just read the theoretical aspect of what an inline function in C++ is, wherein the compiler places a copy of the code at every point where the function is called. So how does this work in real time, or what is the behind the scenes scenario? So let's take an example. Okay, so as you can see on the screen, we have two scenarios. We have a normal function scenario and we have an inline function scenario. So this is what happens when you have a normal function in your program. So we have the start of the program from the main function. So you can see I have written start over here, and then the main function gets started. That is, the execution starts from the main function. And you can see we have a normal function, that is fn1, being called over here. So in this case, the control is being transferred to that function. So what happens is your main function is at one memory location, that is the start of the main function is at one memory location, and the function 1 which we have created, this is a user defined function, so we've created it and it is being stored at some other memory location. Say for example, this is at memory location A, B, C, and this is at memory location X, Y, Z. So the program counter which started off from A, B, C had to be transferred to this memory location in order to locate this function definition. So there is a transfer of control from this point to this function. So this takes a bit of time, which is in usually nanoseconds, but then if there is a huge program which has a lot of function calls, then this becomes an overhead. After the function 1 has completed execution, again the control is transferred back to this main function, and then the remaining part of the main function is being executed. So this is what happens in normal function, wherein there is a control transfer. So as I mentioned, if there are a lot of function calls, so your main function is very big and there are many different functions, there is a lot of control transfer being happening, which basically adds an overhead, and this overhead is generally in terms of time, which makes your program slow. So what happens exactly in inline function? So when you create a function which is declared as inline, so during compile time, the compiler checks if the function is inline, and if it is inline, wherever the function is being called, the entire body of the function is being replaced. So you can see in this scenario we have main function, the function 1 here is inline. So the compiler copied the entire function body and replaced it where the function was called. So basically this is the place where the function was called, but the compiler replaced the entire call by all the code inside the function. So what happens during execution time is that there is no need of control transfer. So you can see that the control is not being transferred anywhere, and since the entire function definition itself is copied in the main function, the execution goes in a linear way. So this saves that little bit of overhead time wherein the function call caused the control transfer from one address to other, as you can see over here. So in small programs this does not have a big impact, but if your program is big and there are a lot of function calls, especially for functions which are very small, for example if you want to just check larger number of 2 numbers and you create a function, that function would have hardly 2 or 3 lines of code. So for that you don't need to transfer the control every time, and instead of that you can use an inline function. So that would save your time because there would be no control transfer in that case. So this is what exactly happens behind the scenes. So now we'll try to see a program which has an inline function. Okay, so I've opened my dev C++ IDE and I've already written down the hash include iostream.h and all the necessary statements which are needed. So we have the int main function you can see over here. So quickly open up your IDE and type out these line of code, and I would recommend that you type along with me so that you get a good practice. So what we are going to do is we are going to create an inline function. So according to the syntax, we need to mention the keyword inline. So I'll say inline, and what we are going to create is we're going to create a function that would return the addition of two numbers. So I'll say inline int add. So it is going to return an integer variable. So I'll say int a comma int b, and I'll define the body here itself so that I don't have to perform a forward declaration. And if you don't know what forward declaration is, I would recommend you to watch the previous video tutorial wherein we discussed what forward declaration means. So inside this, I'll just write one statement. I'll say return a plus b, which is essentially the addition of these two parameters that we'll be passing, and we'll just add them and we'll simply return them because we need to return an integer variable. Now in the main function, I'll just print out a statement. I'll say cout addition of 4 and 5 is, and I'll just call the function over here and I'll pass 4 comma 5. So that's about it. This is a very simple statement, and I'll save this as inline fn .cpp. Let's see if this project compiles. So I'll go to execute and I'll say compile. Okay, as you can see, we have 0 errors and 0 warnings. We got the result. So what happened here is, this is where we called the function, but the compiler knows this is an inline function because we've made it inline. So what exactly it did is, it replaced the entire function call with this body, that is with this entire function itself. So this is what is happening behind the scenes. Of course you cannot see it over here, but this is what is happening behind the scenes. So there is no function transfer or control transfer from main function to this user defined add function. Instead, entire function definition and code is being copied and replaced at this position. So let's try to run this. I will go to execute and run, and there you go, addition of 4 and 5 is 9. Now if I would have created this function without inline keyword, it would have worked just fine. However, as I mentioned, there is a minor overhead between the normal function and inline function, wherein there is a control transfer that is happening which causes some delay in time. Okay, so this was about inline function. Next thing that we'll discuss is about default parameters. Okay, so what are default parameters in functions in C++? So a default argument is a value provided in a function declaration that is automatically assigned by the compiler if caller of the function does not provide a value of the argument with default values. Okay, it sounded a little complex, but it is pretty easy. So what essentially it means is, it allows a function to be called without providing one or more trailing arguments. Now the word or keyword trailing is important, and I'll explain to you in a while. So now you can see a basic function definition wherein we have sum of 4 variables being passed, or sum of 4 parameters being passed, but you can notice that two of these are being highlighted as orange. So these are the default parameters I've been talking about. And what exactly happens is, for example, you want to perform addition of 4 variables. So in this case you can see x, y, z equals to 0 and w equals to 0. So when you pass 4 variables, so you say 5, 1, 2 and 3, all of these would be replacing these parameters. But if you pass only 2 variables, so say for example you just want to perform addition of 2 using the same function, this is possible in the case of default parameters. So let's try to see an example. Okay, so I've created one more file, and this is going to be default parameters in functions. I've already typed in the essential code, so quickly go ahead and type this out. So now we are going to create a function named sum, and it is going to be returning an integer variable. So I'll say int sum. It is going to take 4 parameters, and 2 of them are going to be default. So I'll say int a, int b, int c equals to 0, and int d equals to 5. In the function body, I'll say return a plus b plus c plus d. Okay, so this is a user defined function whose name is sum. It is going to return an integer variable. It has 2 parameters which are normal parameters, and these 2 are default parameters. So let's try to see what exactly default parameters will help us do. So in the main function, I'm going to call this function sum. So I'll just cout sum of 1, 2, 3, 4 is, and I'm simply going to pass 1, 2, 3, 4 over here. We'll save this as default underscore args.cpp. Okay, so as I have passed these 4 values, so 1 would be taking place of A, 2 would be taking place of B, then we have 3 that would be taking place of C, and 4 would be taking place of D. So essentially we should get 1 plus 2 plus 3 plus 4. So let's try to see if this is true. I'll save this again. I'll go to execute, compile and run. So there you go, we got the total, that is 1 plus 2 plus 3 plus 4, which is equal to 10, which is correct, right? So in normal scenarios, even if these two want default parameters, this would be true. But now what if you just want to pass values for these two, A and B, and you don't want to pass any values for C and D, but you want D's value to be default as 5. So in this case, these default parameters are going to help you. So let me just show you the difference between how it is being done over here. I'll just copy and paste this. I'll say sum is, or I'll say sum of 1, 2, 0, 5 is, and here what I'm going to do is I'm just going to pass 1, 2. So 1 is going to take place of A, 2 is going to take place of B, but since we are not passing C and D, or we are not passing any value which would take C and D's place, the default values are going to be included. So C is going to be 0 because we've specified over here that if there is no value coming in from the calling function, we are going to take it as 0, and D is going to be 5. So the total should be 1 plus 2 plus 0 plus 5, which is equal to 8. So let's see if it is true. I'll just save this. Just give a escape sequence endl over here, save it, compile and run. So there you go, we have sum of 1 plus 2 plus 0 plus 5, which is 8. So this is where default parameters come into picture, wherein somehow we want some values to be default if not passed by user. So you get an added functionality, that is, you get an added option that whether you want to pass or not, and if you don't pass, you can assume certain values according to your requirements. One important thing to note down here is default parameters should always start from the right to left. That is, I cannot give C as 0 in between. So this would give me an error. If I save this and I'll say compile and run, this is going to give me an error because there is one variable, or there is one argument to the right of C which is not default. So the rightmost value has to be default. If you are going to add default parameters or default arguments in function, it has to start from the right. So that is one important thing to note down over here. So if I give int D equals to 0, that is make this as a default argument, this is valid. So if I go ahead and compile and run, this would run. But now since this is not a default argument, I need to pass some value over here. So I'll say 3 and save this and compile and run, and this would run successfully. So very important thing to remember that default arguments or default parameters should start from right to left, and you cannot make an argument, a default argument in between. So you cannot go ahead and create this as default parameter because there is a argument to the right of it which is not a default parameter. So instead of making this as default argument, you can make this variable as default argument. So this was all about default parameters. So that's it for this video, guys. I hope you understood the concept of inline functions and what happens behind the scenes and the basic difference between the inline function and normal functions. We also discussed how to use default parameters with functions and what they enable us to achieve, and which basically adds some extra functionality and gives us options. So that's it for this video, guys. I hope you understood both these concepts. If you have any queries, you can always put them in the comment section. And if you like this video, give it a thumbs up, share it with your friends, and don't forget to subscribe to our channel. Peace.